Now, we go to the second example. We have this question. So now we want to investigate the stationary point. The first step, you need to differentiate function and make this function, the answer here equal to 0. So now, what we did here, we find first our stationary point. When we differentiate this y, we'll got here 12x squared minus 4x to the power of 3. And then I make this one equal to 0 because I want to find here stationary point. So here I can factorize this equation. That is, I put outside 4x squared. So it will time here, this one, you will time with 3 minus this one, x. That's why we got this answer. And we know this one is equal to 0. So we can separate into 2 because this is multiplication. 4x squared equal to 0. So x here we got 0. And then for this case, 3 minus x equal to 0. So when we solve this one, x equal to 3. Now we have a stationary points of x, value 0 and 3. We can compute here the point for the y for each x. When x equal to 0 here, our y in this case we substitute. So y is back to the original function. We substitute 0 in this function, we got equal to 0. And then when x equal to 3, we substitute 3 in this original equation. We have y equal to 4 times 3 cubed minus 3 to the power of 4. You solve this one, you got 27. So we have here stationary points of 0, 0, and also this one 3, 27. And then, because we have two stationary points, we need to draw, or we need to have here two tables. The first table is for x equal to 0, and the second one is for x equal to 3. So at stationary point of 0, 0, we can have here x, this one 0, this one negative side of 0, this one positive side of 0. Then we check for each our dy dx here. Of course, this one equal to 0 because we got from this x equal to 0 by make our dy dx equal to 0. But for negative side of 0, we can substitute in this equation, for example, negative 1. So when I substitute negative 1, for example, I have here when x equal to negative 1, y prime equal to 12 times negative 1 squared minus 4 times negative 1 to the power of cube. You will got here 12 minus, so plus 4 here, which is, it is greater than 0, so it is positive. When positive, the slope will be going up. And for 0 positive, I can choose, for example, x equal to 1. I got y prime equal to 12 times 1 squared minus 4 times 1 squared. So 12 minus 4, I got here equal to 8. Still, it is greater than 0, means that it is positive, so will be going up. Means that in this case, the pattern, it is like this. In this case, we can say that it is rising point of inflection. Then we go to the second stationary point, which is at 327. This one, for x here, it is 3 on negative side, the value of 3, and also 3 on positive side. Here we check for our dy dx. This one, when we substitute the value of x equal to 2, for example, in this equation, we'll got here dy dx, our y prime equal to 12 times 2 to the power of 2 minus 4 2 to the power of 3, which is 12 times 4, we got here 48 minus 4 times 8, which is here 32. So we got the answer which is greater than 0, means that it is positive. But when we substitute, for example, the value which is greater than 3, which is, for example, I choose 4, 12 times 4 squared minus 4 to the power of 3. this one you can see you will got here the answer which is less than 0, means that it will going down. In this case, when we plot this one going up, the straight line going down, so we'll have the curve like this, and this is our stationary point, so we can say that we can conclude the nature of the solution at this stationary point is maximum turning point.